Now in section I, this is a continuation a little bit of the previous section H. This is on page 11. So here we have, as an example, we have 5x times 2x. We have 5x times 2x, and we want to simplify this expression, 5x times 2x. We want to simplify it. The way to do that, this is the concept behind it, but so it's 5x times 2x. Now 5x is really, again, like we did before, 5x is 5 times x. And 2x is really 2 times x. So we have 5 times x times 2 times x. You're really supposed to work left to right. However, you have the idea, the concept of the commutative property, which we'll do later. But commutative property basically states that for multiplication, also addition, it doesn't matter the order in which you write the operation. Like 2 times 3 is the same thing as 3 times 2. 1 times 2 times 3 is the same thing as 2 times 3 times 1. It doesn't make a difference the way you write it. So we could rearrange this operation right now, and I could really write 5 times 2 times x times x. So 5 times 2 is 10. That's using the commutative property. 5 times 2 is 10. And x times x, again, is x to the second power, because x times itself twice is x to the second. 10 times x to the squared is 10x squared. That's just how it works. The easier way to do it is, this is the original example. You have 5x times 2x. You're just going to multiply the two numbers together. So 5 times 2 is 10. And then you have two x's together, where you have x1 times x1, which will give you x to the second. We have negative 2y squared times 3y. That's the example. And you have times 3y, that's going to be y to the 1. So you have negative 2 times y squared would be negative 2 times y squared. Y squared is y times y, so we have it like this. Then you have 3y to the 1. That's going to be 3 times y. Y to the 1 becomes y. Now you can rearrange this as negative 2 times 3 times y times y times y. So that becomes negative 6. Then you're left with 3 y's together multiplying by each other. So that's going to be y to the third. Negative 6 times y to the third is negative 6y to the third. That's just the concept behind it. That's a longer way to do the problem. But an easier way to do it is, if you have negative 2y squared times 3y, you just multiply the numbers together and you get negative 6. Then you go on to y squared and y. Y squared times y is y to the third. Now this is question number 1 in the packet. We have negative 3x squared y times a negative x cubed y. If there's no number in front, it's a 1. If there's no number in front, it's 1. And if it's just a negative in front, then it's negative 1. So that's negative 1. And if there's no exponent, again, you can write the number 1, because that means that the exponent is 1. So again, the easier way to do it is you just multiply the numbers first. So we have negative 3 times negative 1 is 3. You can use the calculator. You move on to x. X squared times x to the third. They both have the same base, so you can multiply them together. So you get x to the fifth. And lastly, we have y1 times y1, which would be y to the second power. Again, the way this works is because you first have negative 3x squared y. That's negative 3 times x squared times y. X squared is x times x. Now the other one over here, we have negative 1x cubed y. Negative 1 times x cubed times y. X cubed becomes x times x times x. And we can rearrange it according to the commutative property. We can rearrange this, and we have negative 3 times negative 1 is 3. Then you have 5 x's, so that's x to the fifth. And you have 2 y's, so that's y to the second. 3 times x5 times the y squared is 3x5y squared. That was just a long way to just show how it works, but the first way is the easier way to do it. We'll do number 2 together. I'll do the number 2. So we have 5a cubed x times 2a squared xy. So again, you're just going to multiply. Again, you can also write, if there's no exponent, you can write a number 1 to make it easier. So you're first going to multiply the numbers together. So you have 5 times 2 is 10. You then have a cubed times a squared. And that's going to be a to the fifth, because you add the exponents since they have the same base. And x1 times x1 is x squared. And you're left with y to the 1. So you write y to the 1 power, and that is your final answer. Again, the way that works is because it's 5 times a cubed times x. A cubed is a times a times a. And then the other one, we have 2a squared xy. That's 2 times a squared times x times y. A squared is a times a. You can rearrange it according to the commutative property. It's 5 times 2 is 10. You now have 5 a's multiplying by each other, so it's a to the fifth. You have 2 x's multiplying by each other, so it's x squared. And you're left with a y, so it's 10 times a5 times x squared times y, which is 10a5 x squared y. Number 3, we have negative 3x4y times 4xy y cubed. Again, you could, if there's no exponent, you could write the number 1 because if there's no exponent, the exponent is 1. We have negative 3 times 4 is negative 12. X4 times x1 is x to the 5th. And y1 times y3 is y to the 4th. And that is your final answer. Again, the way that works is it's negative 3 times x4 times y1. X4 is x times itself 4 times. Y1 is y times itself once. And you have 4 times x1 times y3. That's 4 times x times y 3 times. You can rearrange it according to the commutative property. We have negative 12. X times itself 5 times. Y times itself 4 times. And that is your final answer. That is your answer. That is how you do this section. Here are some answers to this section as follows. And that is section I.